Hi, welcome to The Context, where we talk about generative AI.
And in this week's episode, Tiffany, we're going to be talking about cost and latency and how we can get both of those things under control.
Yes, and specifically we will talk about prompt caching, prompt routing, and prompt optimization. Last week, I think we closed a period where we made a few interesting things related to prompt generally available. So we made generally available prompt routing, prompt caching, and now last week prompt optimization. So these are three interesting capabilities that can help reduce cost and improve latency.
So what's prompt optimization?
So prompt optimization is a tool to optimize prompts for specific models. So customers can use it in two ways. To frame their initial prompt. So maybe they have an idea of the prompt, they write the original text of the prompt, then they say, I want to use this with Nova Pro, I want to use this with Anthropic Claude, and they get an optimized version of the prompt for that model. The second use case is if they already have an application using a specific model and they want to change model, maybe they want to move from Llama to Claude or vice versa, this tool can help them optimize the prompt for a different model.
Okay, so I'm looking at the documentation page for Optimize a Prompt. So this is the Amazon Bedrock service for optimizing prompts. This is the one you were talking about, Danilo. So I'm seeing that it supports at the moment a number of different models from different providers here. So we've got the Amazon Nova models, the Anthropic, and some Meta ones as well. And I was just scrolling down here and I can see some of the sample code here as well, which is pretty useful. So it looks as though you've got, so your target model, so presumably the model that you want to target for your prompt, then the prompt goes in here. Okay. Obviously, we've got a couple of functions here which are just helping you unpack what's coming back. So that's what that one's doing there. This is obviously going to handle the response stream from the main piece of code, which I guess is down here. So we've got optimize prompt is the call that we're making, and that's on our Bedrock agent runtime client object we're calling optimize prompt, and it looks pretty straightforward. We're just putting in the prompt in the particular format we need to have that in and telling it the target model that we need it to be. And then we go and process that response. So it looks as though it's likely under the hood here, we're actually using some generative capability to actually be able to create this model. That would make sense to me here, as things we're streaming this back out of the service. And you can, just use this snippet of code, maybe prior to runtime, or maybe you could do something pretty special at runtime. And those are the model IDs or the models that are supported. So that's pretty cool.
How about prompt routing then?
Yeah, prompt routing was another interesting preview that comes from reInvent, is now generally available. Instead of calling directly a specific model, you can call a family of model. And then the router will choose, based on the complexity of the prompt, what's the right level of model to call. So if you, for example, if you're using Anthropic, you can create a router that can route to Claude 3.7 Sonnet and 3.5 Haiku, and then you can the router will decide based on the complexity and some configuration, because you can configure the routing criteria with the routing criteria, will choose which of the two models to call. And the idea is that, of course, the better model will almost always give either the same or a better answer. So you need to define a sort of quality difference. So how much are you okay to compromise on quality to have your request being routed to a less powerful model?
Is it always within the same family of models, or can you do within different families? Like, can you use Anthropic, but also Nova, but also...
That's a very good question, and actually it depends on the implementation. So we decided to go with a single family, and the reason is because the number of permutations. So we technically use something that is a sort of model to decide, a very lightweight model to do that. So if you start to create a lot of complexity and the possibilities, then you need a stronger model to take the decision, and then you lose latency and you introduce cost to do so. So the easiest path that we chose, that I think it gives the best efficiency in the result, is to balance between the same family.
It seems to make sense to me as well that if you keep it in the same family, because the prompt that you send in is not being adjusted, right? It's just being evaluated and which one do you want to send it to. And whilst you might be able to do some prompt optimization and different family members, broadly, you would imagine that in the same family, the same prompt's going to have a reasonable job, do a reasonable job. I guess, Danilo, then this is the classic. I start my conversation with my AI agent saying hello, and it has to respond saying hello back to me. And I don't want to use my most powerful and most expensive model to answer me saying hello. Is that a really simple use case of this technology?
That's you're really hitting the point with this. And in fact, the best way to explain this is also to talk about chatbot applications, because in a chatbot application, you don't control the complexity of the question that comes from the customer. So some questions are very easy, and so you can answer them with a very fast and less costly model. Some questions might be very complex. Maybe they require to use RAG, knowledge bases, maybe with Bedrock and other things. So that maybe gets routed to the more powerful model.
What is prompt caching then?
Prompt caching is a very interesting idea. No, when you call a model, these models, they do a lot of computation to give us the result. And normally, this computation is very heavy, and they repeat a lot of multiplications, these matrix multiplications, iteratively to produce every token of the result. And over time, we started to see model architecture that were optimizing this inside a single invocation. So if you invoke a model and you get an output with a long sentence with many words, many tokens, there were optimization to recycle this multiplication. And the idea was, can we do that also with the next invocation of the model, especially if it's a conversation where you have the same content and then you append more part of this conversation, as often happens. And that's the idea behind prompt caching. So when you use prompt caching with one of the compatible models, as Mike is showing, also Claude 3.7 and Sonnet and also the Nova models. This is the full list. When you invoke this model, you can use the Converse API with Bedrock, and normally you have an alternation of user and assistant messages. And at some point in one of these messages, you can introduce a cache point. There is a specific syntax to introduce a cache point, and that point will be cached if you invoke again the model with the same flow of conversation, the same cache point, and then additional steps of the conversation, all the previous part will recycle some of the computation. So it will be much faster to be evaluated, and then the additional steps are evaluated after that. And it's also cheaper for you because there's normally a lower cost. So a typical scenario is, again, a chat conversation. Maybe when you have large content, maybe you introduce a file like a document in a conversation, and that it's using a lot of the input context. You can introduce, and if you expect that there will be further questions, you can introduce a cache point, and then the next invocation will be faster and cheaper. There's difference in cost depending on the model. So with Nova, we don't introduce an additional cost for caching, and there's a lower cost when you read from the cache. With Anthropic, there is an additional cost when you write into the cache as well, and then there is a reduction when you read from the cache. So in this way, with Nova, there's less risk that if you introduce a cache point, you pay more, because the worst thing that can happen, you don't use it. But with Anthropic, you need to think a little bit more deeply before you do that. So that's how pricing works.
So this cache is not part of the model itself, but it is behind the API endpoint for the model. Is that the right way to think about it?
Yes. And I should have said that currently we cache for 5 minutes. So between invocations, so each invocation starts a new 5 minutes period. So it needs to be something that it's quite interactive. You cannot keep it there for some time and then expect to come back and find it.
And in terms of the applications where this is going to make most sense, so if you have and this is kind of going to be an obvious thing, I think, in terms of how caches work just in general. But if I've got something where the input is constantly different, then obviously I'm going to have cache misses and this isn't going to work for me. But if I have something where I've got consistently the same kind of workloads coming in, then that's going to help me. And would one of those be agentic systems, which are loading in really large, say, for example, really large system prompts? Those system prompts basically start off from a cached point. Am I thinking about this in the right way?
Definitely, because system prompt is part of what you can cache. So that's definitely a good use case with traditional agent architecture that iterate on in a sort of internal conversation that the agent is making with itself and the different tools it has access to. That's definitely a use case.
Yeah, so big system prompts for agents with lots of tools. You stand a chance that this could help out. And I guess the way you find out is by experimenting and seeing if it works for your system.
Exactly, and so when you use the Converse API, there is a metadata section with usage. In this usage section, now you get not only the tokens that have been used in input and output, but you also get the token that has been cached for reads and writes. And also in the metadata section, you get the latency. So you can compare depending on what you want to optimize. Maybe sometimes you want to optimize cost. Sometimes you're interested in seeing more cache reads. Sometimes you want to optimize latency, so you want to look at the difference in latency.
Thanks, Danilo. That's been a really awesome session with a great wrap-up of some new services that we can play around with. If you want to play around with them, then please take a look in the links beneath this video. They're all there, along with the documentation pages as well, so we can all have a play. That's it for this week. And so, until next time, Danilo, Tiffany, thank you so much, and I will see you next week.
See you.
See you.